Okay, hello guys. Welcome back to Math 105 Intro to Algebra. This is Mike coming back at you with another video. In the previous video, we talked about adding and subtracting polynomials. In this video, we are going to talk about multiplying polynomials as well as a special product. Now, the thought or the concept of multiplying polynomials, just on the sound of it, can seem challenging. But it's not as bad as you may think, and it's really not bad, period, if you think of it in the following way. All you have to do is you have to multiply each term in the first polynomial by each term in the second polynomial. After you've done that, you then combine all the like terms. So multiply each term in the first polynomial by each term in the second polynomial, and then combine like terms. But how can we do this in sort of a nice way? We're going to use the distributive property. So we're going to go through several samples of various types here. So first one up, 2 times x squared times negative 3 times x to the third power. This is very nice. This is very basic. We've actually seen something like this earlier on in this chapter. We're just going to multiply the numbers in front, and then we're going to multiply the x's raised to powers. So when we multiply the numbers in front, 2 times negative 3 is negative 6. And then I have the x squared times x to the third power. We're multiplying two exponential expressions here that have the same base, so we add the exponents. So this gives me x to the power of 2 plus 3, or 5. And the second one here, same kind of thing. I will let you guys figure that one out on your own. So next one down, getting a little bit more involved here. 5x times 2 times x to the third. I'll make that just a bit more clear to show that that is clearly a 2, minus 7 times x squared plus 2. So I have this whole thing outside of my grouping symbols here. So what I'm going to do is I am going to distribute this whole thing into each of these three guys there. So this is going to give me the 5x times the 2 times x to the third power. We had the minus sign there. Then the 5x times the 7x squared. And then we had the plus 5x times 2. And we're just going to see what these things are. 5x times 2x cubed. Multiply the 5 and the 2 in front to give me 10. Multiply the x, or x to the 1, and the x cubed to give me x to the fourth power. Minus 5 times the 7 gives me 35, and x times x squared gives me x cubed, and then plus the 5 times 2, or 10, and then times the x. So we have 10 times x to the fourth minus 35 times x to the third power plus 10 times x, or 10x. This one here, very similar. You would be doing the same kind of thing here. Taking this whole thing, multiplying it into each of these terms here. So I'll let you try that one on your own, and we'll go through that one in class. Now, something a little bit more involved, but also at the same time, something more familiar. If you've done any multiplication of polynomials, you've probably dealt with something like this. So 2x plus 1 times the 3x plus 2. So we said we want to multiply every term in the first polynomial by every term in the second polynomial. So what I'm going to do and how I want to sort of introduce this to you and how I want you to begin to think of it more is let's take the first term in the first polynomial and I will distribute that to the entire second polynomial. So going into this whole thing. So what I'm saying is let's do 2x times 3x plus 2. And now going back to the first polynomial, we had a plus sign there. It's hard to tell because the pencil went over it, but we have a plus sign there. And now I'll take the second term and I will distribute that into the entire second polynomial. So I have the 2x times the 3x plus 2 plus the 1 times the 3x plus 2. And now we're just going to do just like we did in the problem up here. I'm going to take this thing that I have out front and I'm going to distribute it to each thing in here. So this gives me the 2x times the 3x plus the 2x times the 2. And then I'm going to do the same thing with the 1 times the 3x plus 2. I'll take the 1, I will distribute it into each term in here. So I have plus 1 times 3x plus 1 times 2. So now we will multiply these things and we will combine like terms. So 2x times 3x, 6 times x squared, 2x times 2 is 4x, 1 times 3x is 3x, and 1 times 2 is 2. But now we have some like terms here. I have the plus 4x and the plus 3x. I can combine those. So I have the 6x squared, now plus 7x and plus 2. We'll look at something that seems more complicated, may seem like we have to do something different, but we don't. We're actually doing just the exact same thing. 2 times x to the third plus x times x squared plus x. We're going to look at this the exact same way. I'm going to take the first term in the first polynomial, and I will distribute that to the entire second polynomial. So this will give me 2 times x to the third times x squared plus x. And now we take the sign that we had in the first polynomial, plus, and then the second term, and I would distribute that to the entire second polynomial. So x times x squared plus x. So I have this thing here. I will distribute this 2 times x to the third into each of these two terms here. I'm going to multiply and I'm going to combine them. So I have the 2 times x to the third times x squared. That's going to give me 2 times x to the 5th plus 2 times x to the 3rd times x. That gives me 2 times x to the 4th power. So those are those two terms. That's simplifying this here. Now plus x times x squared, which gives me x to the 3rd, and then plus x times x, or x squared. There are no like terms here, so we can't simplify it any further. This is just what it is. Now, these last two problems that we've done here, these guys on their own are each called binomials. They're binomials because they have two terms, and we were multiplying two binomials. So you may be familiar with the concept of FOIL. You know, first, outside, inside, last. And you may be thinking, okay, well, why didn't you just say FOIL? You know, why didn't we just do, you know, first, outside, inside, last? Well, there's a reason why, and it's because FOIL only works when you're multiplying two binomials. It doesn't help us if we are multiplying, say, a binomial and a trinomial, or a trinomial and a trinomial, or something like that. FOIL only works in sort of one particular case. So this is why I want you to think of multiplying polynomials as multiply every term in the first polynomial by every term in the second polynomial, and we do that through using the distributive property. We'll go on and we'll see a couple samples as to why we want to look at it that way. So first one here, x plus 1 times 2x squared plus x plus 1. So again, we're going to look at it the same kind of way. Take the first term in the first polynomial, and we will distribute that to the entire second polynomial. So that's going to give me x times 2x squared plus x plus 1. Then, again, we have a plus sign here, plus, and then the second term being distributed to the entire second polynomial. So plus 1 times 2x squared plus x plus 1. So now the x is going to be distributed to each of these three terms here. It's going to give me 2x cubed, or 2x to the 3rd power, plus x times x, or x squared, and then plus x. And then plus 1 times 2x squared, or 2x squared, 1 times x gives me x, and then 1 times 1 gives me 1. So now, can we combine any of these like terms here? I have the 2x to the 3rd all on its own. There's no other x raised to the 3rd power here, so that just has to come down. I have a plus 1x squared plus a 2x squared. It gives me plus 3x squared. I have a plus x and a plus x to give me plus 2x. And then I have the plus 1 at the end. So this is one example of why we don't just want to think FOIL, because FOIL only helps us in that one particular case. We'll go on to the most challenging type of problem you would see from me, a trinomial, something with 3 terms, times another trinomial. So again, go term by term. First term, distribute it into the entire second polynomial. So x squared times x to the third plus 2x minus 4. Now we have minus the second term distributed into the entire second polynomial. Minus 3x times x to the third plus 2x minus 4. And then minus, because that's the sign we had there, 2, the third term in the first polynomial, distributed to the entire second polynomial. So now we have a lot of simplifying here. I have x squared times x to the third, which gives me x to the fifth. X squared times a positive 2x gives me plus 2x to the third. Then an x squared times a negative 4, or times a minus 4, gives me minus 4x squared. Now, paying close attention to the minus sign we have in front, I have a minus 3x times the x to the third is minus 3 times x to the fourth. Minus 3x times a positive 2x gives me minus 6x squared. And minus 3x times minus 4 gives me plus 12x. And lastly, minus 2 times x to the third is minus 2 times x to the third. Minus 2 times a positive 2x is a minus 4x. And minus 2 times minus 4 is plus 8. So now we have a lot of terms that we have to simplify here. I have the x to the fifth. There's no other x to the power of 5 in here. I see I have a minus 3x to the fourth. No other x raised to the fourth power here. Let's look at the x to the thirds. I have a plus 2 times x to the third, and I have a minus 2x to the third. So plus 2x to the third minus 2x to the third, those guys are actually just going to cancel out. Next, I have a minus 4x squared and a minus 6x squared. I can combine those to give me minus 10x squared. I have the plus 12x and the minus 4x. Those combine to give me plus 8x. And then I just have the plus 8 at the end. So this is, again, why I want you to look at multiplication of polynomials as each term in the first polynomial being distributed into the entire second polynomial. That way we're making sure that every term in the first polynomial gets multiplied by every term in the second polynomial. And then once we did all that, we combined all of our like terms. Now before we end this video, I want to talk about a special kind of product that we have that does tend to come up a lot when we deal with these polynomials and a specific type of equation that we will be looking at in our next chapter. what if I'm multiplying two binomials where the terms themselves are the same, but the sign in the middle of them is just switched? So here I have x plus 4 times x minus 4. So x plus 4 times x minus 4. Well, again, first term of first polynomial distributed into the entire second polynomial. Carry the sign over, plus the second term in the first polynomial distributed into or times the entire second polynomial. So this will give me x squared minus 4x there. This will give me plus 4x minus 16. Well, I have the minus 4x plus 4x. Those guys just cancel each other out. So I'm just left with x squared minus 16. But note that 16 is just 4 squared. So when I did x plus 4 times x minus 4, I got x squared minus 4 squared. This result is generally true for any terms a and b whatsoever. It could be two variables, it could be two numbers, it could be one number and one variable, whatever. A plus b times a minus b is equal to a squared minus b squared. So we will be seeing this happening quite a bit as we get later on in our course. So guys, this concludes our video on multiplication of polynomials. If you have any questions or comments, please be sure to reach out to me. Email, voicemail, stop into my office hours, stop into my tutoring hours, flare signals, SOS bonfires, telegrams, carrier pigeons, whatever you have to do. Until the next video, take it easy, guys.